All right, I'm on now. Okay, I can see that. All right, so we have two people here. Can you hear me now? If you can hear me, let me know in the chat box. All right, that's fine. So please inform them to join now. I'm starting immediately. Sorry for the network break. The network was disturbing, and so I had to start another stream and end the first one and the second one also because you could not hear me. Now that you can hear me, let's go directly into the lecture. Level measurements. All right. Somebody is talking about attendance. Yes, I am noticing the attendance myself. You understand? Okay. So we are looking at level measurements today. In our previous class, we discussed about flow measurements. We discussed about flow measurements that we can measure flow of a fluid in a channel, whether in a tube or an open channel. And we discussed several devices such as the orifice plate, such as the flow nozzle, venturi tube, and weirs and fluids that can be used to measure flow in an open channel. While the other devices, orifice plates, venturi tube, and flow nozzle, they are used in a closed channel, and they are used to measure differential pressure because they create a difference in the pressure of flow in a particular channel. So we learned that in our previous class. Now we want to go to level measurements. Now, what do we mean by level measurement? Level measurement has to do with it is related to fluid flow systems when it's necessary, such as in a storage tank. You know, sometimes these levels are measured and the value are transmitted to remote monitors or central control stations, whereby they could trigger automatic level control. When you have a storage tank, overhead tank somewhere, and then you are using the fluid industrial process, and then the stored fluid must not run out. The manufacturing must continue, using this stored fluid in the storage tank. And so there should be a monitor that checks what is being used, what is coming in to the storage, and the level in the storage so that it does not run dry, it does not run out in the storage. So we need level measurements to do this. Level measurements will be able to also provide automatic control so that the level in the tank, when it is being used, when it's being drained out, another source will be filling it back. A automatic control will be able to do that, but you cannot control something except if you can actually measure it. And so tanks, vessels, reservoirs, heights of column in open channel streams, and various other similar, situations in industrial processes need level measurement. They require level measurement. Not only that, even in some other manufacturing industry where they use some substance, for instance, at the cement plants, for instance, where they bring the raw materials for cement, the laterites, the shale, the limestone. When they crush them and bring them together, there is a particular point where they dump them in a very large tank, and there is a level measurement that is sensing the level or the quantity that of this material, this sand material that are brought together to start the process of cement making. So the level must not go beyond certain stage, and then so we'll be able to discuss about one or two level measurement systems. We actually have so many different level measurement systems, so many level measurement devices, which include a resistive method, whereby a resistance method is used to take measurements. We also have what we call float method. You must have come across uh, some of these points before, probably in the notes or in your own personal reading. All right, we have float measurements. Then we have what we call force balanced diaphragm system. Force balanced diaphragm system. That's another one. Then we have another one called bubbler or purge system. Bubbler or purge system. Then apart from that, we have another one, the capacitive method, using a method of capacitance to form measurements. Then we have the sonic method, ultrasonic method, which is working on a high frequency. And then another one is radiation method. Radiation method, using rays like gamma rays to take a level of something and convert that into measurements. All right. We have about 7 different systems of level measurements, and then today I'm going to discuss systems of level measurements. And then today, you can let me know in chat if you can hear me. You can actually type something in chat to confirm to me that you are hearing me. Let everybody confirm to me in chat that you are hearing me. So, can you hear me now? I want everybody to confirm by saying yes or hi. Just say yes or hi in the chat box. All right, Oluwafemi, I see you. Say you are hearing me. That's fine. Olanrewaju Ogundimu say hi. Yeah. Emedo Ovie, yes. Egbedo Abdurrashid, yes. Gospel Pilot, hi. That's fine. So, okay, Awushika Shegun, yes, that's fine. So we can go on now to discuss about uh, the resistive method of level measurements. Resistive method of level measurements. Now, liquid level is measured in meters. Okay, it's measured in meter method of measuring liquid level, the simplest of them all. And this is known as a contact point method. Contact point method. Now, uh, later on, you'll be seeing the picture of that, how this is done in the illustration, the schematic representation. Now, in the system, what we have is that we have a mercury column, you know, and this the liquid level is carried out, you know, by means of this mercury column, which is actually operated by a liquid column. Now, the liquid is connected to the same column where there is mercury. Now, this mercury will be moved or displaced around something like a U tube. And you know, mercury is a metal. And we have a bank of resistors, like series terminals arranged in the tube, in the vertical side. So when the mercury moves, it comes around and begin to connect these resistances together one by one, depending on the level of the fluid in the tank, whereby the fluid is the one operating the, you know, the mercury column, pushing the mercury column to, they are connected, all of them become parallel connected when all of them are connected, or how many that are connected. So we have resistors arranged like that in the tube. They have been connected in one side, all of them were connected in one side, in one terminal each together, linked in parallel. But the other terminal is left open in the mercury column. And the mercury column is not always connecting them. Connects them depending on the level of fluid in the tank. When the fluid in the tank is going up, it will be pushing the mercury to be, you know, connecting up the resistors one after the other. And now these resistances, they are in a circuit, you know, the resistors are in a circuit whereby there's a meter powered, you know, by EMF. So, so the meter will be able to indicate the current flowing in the circuit. Now, depending on the fluid of the level of the fluid in the tank, that is what determines where the mercury column rises to. So when the mercury column rises to several resistors, all of them that are being linked will be connected in parallel. At that point, we have least resistance. And when we connect all of them together, we have least resistance. When you connect resistances in parallel, you have the smallest resistance, the resistance that is even smaller than one of the resistances connected. So at that point, we have highest current flowing in the circuit. And that highest current flowing in the circuit will be indicated by the meter, is connected in the circuit. So the meter will read a very high value, and that shows high level of fluid in the tank. When there is a little level of fluid in the tank, what you discover is that the mercury column comes down and disconnects most of the resistance. When most of the resistances are disconnected, only few are connected, and when only few are connected, we have higher resistance as the effective resistance for all the connected resistors. In that case, there will be high resistance in the circuit, and then there will be least, current flow in the circuit, and the meter reads least, deflects a little, and that shows that that is an indication that there is a low level of fluid in the tank. A low level of fluid in the tank. Now, when you have that, what you can reason out is that the measurement of current is proportional to the level of fluid in the tank. Low level of fluid will result into low current reading on the meter. And when there is high level of fluid in the tank, there will be high current reading. And that means they are proportional. The reading of the ammeter is proportional to the level of fluid in the tank. Reading of the ammeter, whether low or high, is proportional to the level of fluid in the tank. Now, what we also notice here is that the reading on the ammeter is inversely proportional to the total resistance, in the circuit. And the total resistance will depend on how many of the resistors are connected up on the second side. All one side have been connected together, but other terminals of each resistor are left open for the mercury column to link them up. So the mercury, which is actually a liquid metal, will be linking them up one by one, depending on the level of fluid in the tank. When the fluid is increasing in the tank, then the mercury column will be operated more, will be pushed to go up to the resistances. If the tank is full, the mercury goes to the highest point and connects all the resistors together. At that point, we have the least resistance. We now realize that height of the fluid in the tank is inversely proportional to the value of the resistance in the circuit and directly proportional to the current reading on the ammeter. For that reason, a measurement of the current on the ammeter is taken as a measurement of the height of fluid in the tank. In the tank, we have low level of currents on the ammeter. When there is high level of fluid in the tank, we have high level of current reading on the ammeter. And the ammeter is calibrated in terms of the liquid level. Instead of calibrating it as measurement of current, it is calibrated. It's a very measurement has its advantages. It has its advantages. One, the advantage is that it is simple and is capable of indicating liquid level directly. You get the liquid level directly read out on the meter, on the ammeter. Liquid in the tank is proportionally simple to set up. Number two, the system operates on low voltage, and so there's no danger to the operator and no possibility of arcing at the contact point. Even though the resistors are in contact with the mercury, which invariably is in contact with the fluid in the tank. The system is operated using low voltage, so there's no danger that there will be electric shock. If it is using high voltage, then there will be a danger that there will be electric shock, but there's nothing like that. It's using low voltage. DC, it's actually using DC voltage, so there's no fear for the operator, fearing electric shock because it's operated on low voltage. That's one second advantage. The third advantage is that the signal can be transmitted to any desired point. Any desired point, the signal can be transmitted. Even though it is measured at a particular location, then you can transmit it far away so that it can be used maybe for control purposes, like in a control room. In a control system, the value can be, directed to the control system to actually do certain control action. That's another advantage. Number four, the reading record is fairly continuous. Fairly continuous record of liquid level can be obtained, and that can be achieved when we add more resistances in the column, the mercury column. When you add more resistances, then it means you are going to have varying level of resistances developed as mercury column is operated, and then it's connecting different values of resistances, different number of resistance, resulting in different value of effective resistance in that circuit. Now, by doing that, there will be separate signal output for each contact resistance. Each resistance that is connected will give a different value of effective resistance. And when that happens, it means you are going to have another value of current for that particular resistance. If resistance. And when that happens, it means you are going to have another value of current for that particular resistance. So that's many values of liquid level measurement. If you can add as many as possible resistances in the parallel combination of resistors. Remember, the resistors are connected on one side, one terminal each of all the resistors will be connected and linked to the power supply, in which there is a meter to take measurement. And then other end of the resistances are left open in the column, in the tube, whereby when fluid is coming into the tank, it will be pressing down on the mercury column, and the mercury column to connect all the resistors in parallel, one after the other, resulting in different value of resistances, effective resistance in the circuit. So those are the advantages of the resistive method of level measurement. Now, disadvantages. No matter how much advantages you have, there will definitely be disadvantages. All right. Somebody is asking a question. I see a question from Oluwafemi Adeniji. When resistances are connected in parallel, we have least what, sir? Okay. What I'm saying is that when you have resistors in parallel, if each resistor is having, for instance, value of 2, 3, 4, 5 resistance in parallel, and you take the measurement or you do the calculation, the value you are going to get is going to be less than even the least value that you have. The least value that you have in this example I just gave is 2 ohms. When you calculate all the resistors value in parallel, when you have 2, 3, 4, 5 ohms in parallel, the value you are getting is less than 2, which is the smallest of them all. So that's why we said that we are going to have the total effective resistance to be the least when you connect all of them in parallel. I hope you get that, Femi. I hope you get that, Femi. All right, Femi, I hope you are hearing me. You said the network is bad, but I still hope you can hear me. All right. Now, let me quickly finish up the disadvantages of the resistive method of level measurements. Let me quickly talk about the disadvantages. Now, the disadvantages are few. The first one is that the major disadvantage is that the liquid may lead to the system may lead to serious error in measurement. The liquid may lead to serious error in measurement. The liquid that we are measuring can lead to error in measurement, because it's possible that the liquid is conducting or it may not be conducting, so it can lead to error in the measurements. All right, that's a disadvantage. And then the second disadvantage is that the measuring system has to be calibrated differently for different liquids. And that's the point we are making now. When you use the device to measure for one liquid, the value you get on your meter after calibrating it will be different when you are measuring another liquid. If you are measuring, for instance, you are measuring water. Let me use water for example. Water is a different type of liquid. And then when you are measuring fuel like probably PMS, the petrol. This fuel, they have different density, viscosity, and so on and so forth. So you have to recalibrate the device, the resistive level measurement. You have to recalibrate the system to measure, tank. So that's the disadvantage. So you have to be recalibrating each time you are using this system to measure different liquid levels. So that's the disadvantage there. I hope you get that. So now I don't know whether anybody still has a question. I will pause here before we go to the second one for today, which is a float level float method of level measurement. Float method of level measurement. So I want to pause here so to see your questions. So let me see your question in the chat. All right, I can see that you can hear me. All right, we have 14 people here. Please, all of you should click like the live stream and also subscribe to the channel. I've not seen most of you subscribe to the channel. Click subscribe to the channel now. It doesn't cost you anything just to click subscribe. Then you can also hit the notification button. Another time when we are uploading video, you'll be notified so that you can easily be notified. All right. All right, Adeniji, yes, I mentioned the advantages and disadvantages of resistive method of liquid level measurement. Resistive method of liquid level measurement that I've just discussed. I just discussed the system, how to design it technically using resistors and a mercury column. So I discussed the advantages of this system and then its disadvantages. That's what I discussed. I hope you can hear me now, Femi. Can you hear me, Femi? All right. Did you get that explanation regarding your question on advantages and disadvantages? Did you get the explanation? So I want any other person to actually, uh, ask question. I want you to ask your question before I discuss the second one for today. So I think we can stop after discussing the second one so that because of data network issues and the like, so that we don't stay too long. So anybody that has a question should actually uh, ask his question now. Now I want to know those that are present. I can see Femi. I'm taking a attendance. Ṣẹ́gun Awaka, Felix Opeyemi, okay, Pablo, Flick Gaming, Banks. So these people should chat me later to tell me, their matric number. Everybody that connected should chat me, show me your matriculation number. All right. Timira's Rhapsody. Okay. Popola Abdul Malik. You okay? You are the Flick Gaming. That's fine. Popola Malik. That's fine. Now, the Olawale, let me see whether Olawale is here. I can see Abiodun Olamide Adeleye. Okay, so any question that you have, please type your question. I am pausing a little bit now to receive your question. Gospel Pilot, all right, Aziz Olawale. That's fine. Gina Adelumide, yes. That's fine. Tenitola Adekambi. Okay. Now, Olawale, can you actually see the people that are connected? Can you write their name? Omayeni Unile. That's fine. So make sure you actually, click subscribe and like the live stream. Click like and subscribe. I think you get it. So, right. So let's continue. No, Olanrewaju Ogundimu, we see you. I think there is no question now again. So we want to go to the second system of liquid level measurements that we are discussing today. We are discussing only two today. Only two. All right. All right. We can see Anthony General. Anthony General. That's fine. Now, what I will do is I will save all your name even into screenshots here, so that we can know those that actually participated here in the class today. All right. So before I continue, let me also ask once again. Does anybody have a question? Please ask on the the one we discussed. The one we discussed, that is a resistive method of liquid level measurement. Resistive method of liquid level measurement. Does anybody have a question? If not, I will move on to the second one immediately. So if you want me to continue now, type yes. You want me to continue, just type yes. Let me see you type yes. Type yes if you want me to continue, so that I can continue. All right. All right. I'm seeing your yes. Okay. I'm going forward immediately. Okay. I'm seeing your yes. Javier and everybody. Now, the float method of liquid level measurement. Float method of liquid level measurement. Liquid level measurement. Now, some of you, most of you must have noticed that thing that we call float, that device that we call float, but you might not know how it is used, or you might not recognize that that is the float. Now, I will give you a very simple, the commonest example you can see of a float. That is in your toilet, in the water closet in your toilet. You will see that there is a tank behind the closet seat. The tank behind stores water to be used to flush you know the toilet, the WC rather, to flush the WC, the water closet. Now, inside the tank, there is a system whereby water will be coming to the tank, and there's a float system, a float switch, mechanical float switch used by the plumbers. Now, when they install it, when there's no water in the tank, they float like a ball, like a blue ball, black ball, red ball, or green colored ball. It goes down to the bottom of the tank, that small tank. Okay. Now, when water begin to come into the tank, it begin to carry the float up. As it's carrying the float up, the float is activating the switch from which water is coming in. As water is rising up in the tank, it carries the float up little by little, and gradually the switch, where the water is coming in, will be locked. When the water is full in the tank, the float comes to the maximum, point, that is the top of the liquid, and then it effectively shuts out the water coming in. By that, the tank will not overflow with water. But you will not be the one to go and shut the faucet, or open the faucet by yourself. No, it is an automatic system. The water coming in is bringing up the float like a ball, that green ball, green color ball, or blue colored, or red color, or black color plastic ball that you see on top of the water. As the water comes up, it energizes the switch and effectively closes where water is coming in. So that ball is actually the float. Even the ordinary soccer ball, when it's well inflated, if you carry it and put it on surface of water, it stays on top. It will not go and sink into the water. So that system can also be used, that such a kind of system has been developed to work as a liquid level measurement. And this flow system is also being used for overhead water tank for domestic use. Overhead water tank at home. You see, many houses have a storage tank for water, whereby water stored for the use in the house is pumped into the overhead tank, and then when the water is being pumped, when it is full, if there is a level switch there, the water will be shut out. It will be locked. The entrance from the pipe bringing water into the tank will be stopped by the float switch. But you discover that in many houses in Nigeria, this is not being done. There is no switch. And then some people, when they forget to turn off their water pump, and they left the house, locked the door, went to work. Sometimes when there was power failure, they forgot to, turn off the water pump. And then when power is restored, what will now happen is that the water pump begin to pump water into the tank. The tank is full and is now pouring water into the compound continuously for several hours when the owners are not available in the house. That's what usually happens in many places. That should not happen in the house of an engineer, such as you people, engineer in the making. should not allow that to happen in your house. There is automatic system that can turn off the water pump, the electric motor that is pumping the water. You don't have to design it yourself. And of course, you can design it yourself, or perhaps use it as a practical project. But it's actually available in the market. You can buy it and install to your water tank. Meanwhile, all these I've explained, they are just a kind of digression. I just want you to have a general background when we talk about floats, a general background. Now, let's come to the float method of liquid level measurement. What happens is that a float is placed on the top of the fluid in the storage tank, and the float will actuate a switch. Then it will now be able to take measurements or perhaps transmit a signal to a remote equipment. The float is a mechanically coupled device which is actually connected to a displacement transducer. And when we say displacement transducer, we are talking about devices such as potentiometer or LVDT. A potentiometer is actually a resistive transducer whereby it's basically a variable resistor that has a wiper connected to it, and the wiper is connected to a body that is capable of linear displacement, either right, left, or probably rotary movement, going clockwise or counterclockwise. So either way, the potentiometer will be varying its resistance based on the body that is having motion, either linearly or in rotary direction, clockwise or counterclockwise. Now, for float's method of liquid level measurements, the float is connected to a transducer such as potentiometer or LVDT. And when the float is moving up or down on top of the liquid, it's changing the resistance of the potentiometer or the LVDT. I hope you people remember what LVDT is. Linear variable differential transformer. Now, there is a sketch that indicates this procedure that you will see